What's up, guys? This is Phillip with the Desmos Visionary. I'm here with an awesome function, and this is kind of a follow-up to my last video, because the entire purpose of my last video was to figure out a way to get this function here, which is a semicircle, followed by another semicircle, and another semicircle, on and on and on. And I found a way to define just one semicircle after the other, and just use the list to define several of them with piecewise defined function. But what I didn't do was create one explicit formula that is this, and that is the goal of this video. So I have of course found it because you're looking at it right now, and so I'm going to talk about how I got there. So it all starts with this function. You see, I was thinking about how to make this section of the graph around x, right around here, repeat several times, because that's what I would need in order to get a repeating function for circles. So I was thinking about how to go about doing that. So I thought, well, what if I just start with the floor function, and then I make it negative, and I add it to x, and then I get all these little x's that stay in one place, which is kind of basically what I want. So I just needed to manipulate this into a form that I could use it. So I said, well, let's make these lines 10 long, because that's the length of the semicircle that I want to end up with. And then I've got to change this to be subtracting the same amount as its length in order for these to line up on the origin. So I did that. So now I have this fun little function here. And yeah, we'll go ahead and add x to it. And now we see we have this repeating stuff here. But the problem with this is that it ends at 0 and 10, and I want it to end at -5 and +5. So I actually need to shift the graph over a little bit. I'm going to do that by subtracting 5 from there and from there. And that is going to give us this nice function here that has its ends at -5 and +5. Finally, all I need to do is shift this down, because x goes to the origin, and these do not go through the origin. And so I need to shift this point down to the origin. And we're going to do that by subtracting 5 more. And what I get here is this wonderful repeating x, which I'm going to use to make several circles. So I went ahead and defined that up here as my big X of x function. So we're going to come back to that. But you can see the idea here is that we're going to take the square root of 25 minus x squared, and that gives us this. And if we take 25 minus big X of x squared, which is what this function is, then it gives us this, which is this repeating circle. But the only thing is that I wanted it to be, this circle to be negative, and this one to be positive, and this one to be negative. It was going to be really cool. And that's not what this is yet. So we got to find a way to make every other circle negative. And the way we're going to go about doing that is with a function that just oscillates between -1 and +1. And there are a few ways to do that. I chose a wonkier way than most, but I'm having fun here, so who cares? We start with the cosine function, which does in some way oscillate between 1 and -1. And we're going to go ahead and multiply this by 2 pi, and then divide by 20, and that's going to make the length of the period of the cosine function 20, which is important. We'll simplify that to pi x over 10. And so then what we can do is we can take the floor function of this, and that gives us this 1 and 0 and -1, but it just gives us this weird plot point here at 0, 1. So if I go ahead and multiply this by a number that's less than 1, then it's going to get rid of that, because the floor function is going to give us a value of 1 if it ever reaches 1. So what we have to do is make sure that this line doesn't exceed 1, and we do that by multiplying it by, say, 0.5. So we take the floor function and we get 0, -1. Now it gets tricky because I have 0 and -1, but I want +1 and -1. So the way I'm going to go about doing that is if I add 0.5, then I get this +1/2 and -1/2. Then all I have to do is multiply by 2, and I get this +1 and -1. So now I have all the tools that I need to make this happen. We're going to go with the square root of 25 minus big X of little x squared, which we saw before. And now all I have to do is multiply it by this little g of x, and I get the function I was looking for, which is pretty neat. I'll go ahead and graph my original functions here. So this function is pretty cool, and it's a neat solution to it. There are several ways we could do this oscillating -1, +1, but hopefully you guys can use this to be inspired to find some other pretty interesting functions that you wouldn't normally think you could get with some creative applications of the floor function. Well, thanks for watching. I really enjoyed making this graph, and I hope you guys enjoyed this video. I'm going to leave the Desmos Graph link in the comments if you want to go play with it. Thanks for watching. I'm Phillip with the Desmos Visionary.